Hello students. So we shall begin with permutations and combinations, which is a chapter for class 11. So this is a very interesting topic, and before we even start with permutations and combinations and deal with the related formulas, the first exercise, which is exercise 7.1, deals with a few fundamental problems which can be solved without knowing the formulas related to permutation or combination. Right? So by using basic logic and understanding, we can solve the problems given in the first exercise. So let us begin with the first problem. So exercise 7.1. The first problem: in how many ways 3-digit numbers can be formed from 1, 2, 3, 4, 5? The first one, where repetition is allowed, and 2, where repetition is not allowed. Right? So using 5 numbers, I need to form a 3-digit number. So you have a 3-digit number which needs to be formed, and in the first case repetition is allowed. That means let this be the units place, tens place and hundreds place. In the units place, I can have any one of these 5 numbers, so there are 5 possibilities. In the tens place, I can have any one of these 5 numbers, so I have 5 possibilities. And again in the hundreds place, I can have any one of these 5 numbers, which again is 5 possibilities. So how many different 3-digit numbers can we have? So it's going to be 5 into 5 into 5, which is 25 into 5, which is 125. So 125 3-digit numbers can be formed using 1, 2, 3, 4, 5 with repetition. Now without repetition, again we have the units place, the tens place and the hundreds place. Now in the units place, let's say I choose one among these 5 numbers. So I have 5 ways. Okay. Now let's assume that I've chosen one of the number. When I've chosen one number here, I'm left with 4, the remaining 4 numbers, because repetition is not allowed. For example, if I choose 1 here, the number 1, I cannot choose 1 for the tens or in the hundreds place because repetition is not allowed. So therefore, I am left with 4 numbers. So in the tens place, I can choose any one of the remaining 4 numbers, and in the hundreds place, I can choose any one among the 3 remaining numbers. So how many different numbers can I have? So it's going to be 5 into 4 into 3. So 5 4s are 20, 20 into 3 gives me 60 ways. So very easy problem. So let's move on with the second one. How many 3-digit even numbers can be formed from 1, 2, 3, 4, 5, 6 if repetition is allowed? So repetition is being allowed. So again, it's a 3-digit number. So you have the units place. So we have the units place, tens place and the hundreds place. So we need a 3-digit even number. Now an even number is formed only when in the units place I have either 2, 4 or 6. If I have 1, 3 and 5, it becomes an odd number. So the units place can have one of these 3 only. So there are 3 ways of filling in the units place. Then since repetition is allowed, in the tens place, I can have any one of these 6 numbers, and again in the hundreds place, any one of the 6 numbers. So how many possible ways? It's 6 into 6 into 3, which is 108 ways. Again, a very simple problem. How many 4-letter code words can be constructed using the first 10 letters of the English alphabet if no letter is? So here in this problem, by using the first 10 letters, we create a code. So the code consists of 10 alphabets, right? So let this be position 1, 2, 3, 4, and the alphabets cannot be repeated. So let's assume that in position 1, I can choose any one of these 10 alphabets, right? The first 10 English alphabets. So since one alphabet has been chosen, I'm left with 9. So in the second place, I can choose 9. Now in the third place, I can choose 8, the remaining 8, and in the fourth place, I can choose 7. So how many possible ways? It's going to be 7 into 8 into 9 into 10. So when you multiply all these 4 numbers, so you get 5040 ways. So you can actually have 5040 different 4-digit codes using the first 10 alphabets of the language English. Question 4. How many 5-digit phone numbers using the numbers 0 to 9 can be formed if each number starts with 6, 7 and no digit appears more than once, right? So you have a 5-digit phone number, 1, 2, 3, 4, 5, right? So let this be position 1, 2, 3, 4 and 5. Now it's been given that this 5-digit phone number begins with 6 and 7, right? So in the first and the second place, that is the first two numbers, here I need to have 6 only, so there's only one way. In the second position it has to be 7, so there is only one way, and none of the numbers appear more than once. That means out of the 10 I've already used 2, so how many are remaining? 8. So one number is chosen here. How many are remaining? 7. So one number is chosen here. Now how many numbers are remaining? 6. So how many different possible telephone numbers can be formed? It's going to be 8 into 7 into 6. So when you calculate, you get this as 336. A very easy problem. Now fifth one, a coin is tossed 3 times and the outcomes are recorded. How many outcomes are there? So a coin is tossed 3 times. So if a coin is tossed once, you get 2 outcomes, right? Now a coin is tossed again, you get 2 more outcomes, and a coin is tossed the third time, you again get 2 outcomes, because the outcome of tossing a coin is either head or a tail. So once you toss, you get head or tail, 2 outcomes. You toss it twice, the second time you get 2 outcomes, and you toss it the third time, you again get 2 outcomes. So 2 into 2 into 2 gives 8. So very simple problem. Next, sixth one. 5 flags of different colors are there. How many different signals can be generated if each signal uses 2 flags, one below the other, right? So you have a signal and you have a flag. So you have a signal and there are 5 flags, and each signal uses 2 flags, right? So you have 5 different flags, each flag is of a different color, and each signal uses 2 flags, right? So this is a signal here, one flag and the other flag below it. So among the 5 different flags, I can choose one among them here. So there are 5 ways. So one flag is chosen of a particular color. How many are remaining? 4. So you have 4 here. So what is 5 into 4? It is 20. So how many different types of signals can be generated? You basically can have 20 different types of signals, where each signal will have 2 different colored flags, one below the other, right? So these are the questions given in exercise 7.1. So you must have realized that all these questions are very easy, right? And we have not yet dealt with the formulas of either permutation or combination as such, right? So by using basic understanding and logic, we have solved all these questions, right? So in the next video segment, we shall go through permutation and solve the other exercises from this chapter. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And thanks for watching.